Assalamualaikum. My name is Nur Farhana Wahida and my number is 23057. I will explain about the interaction of heat engine. First of all, is energy. Energy is cover the basic of energy. Energy is a fundamental concept in physics and refers to the capacity to accomplish work. There are various forms of energy, including heat, light, motion, electrical, chemical, and gravitational. However, energy cannot be manufactured or destroyed. It can only be converted from one form to another. This concept is known as the first law of thermodynamics. There are two primary categories. Is renewable and not renewable. Renewable energy sources such as solar, wind, and hydroelectric power can be replenished naturally and are generally more sustainable. Non-renewable energy resources such as fossil fuel are finite and have a more significant environmental impact. Two primary categories of energy for incubation work are potential or stored energy and kinetic of working energy. Potential energy is energy that is stored and can be converted into kinetic energy when needed. Kinetic energy is energy in motion. The second is exergy. Exergy is a thermodynamic concept that refers to the amount of work a system can perform when it is brought to a state of thermodynamic equilibrium. Exergy is a measure of energy, quality, and value, and it is distinct from energy, which is a measure of quantity. Exergy can be created and destroyed in each transformation process, while energy is conserved in every transformation process. The portion of an energy flow that can be utilized to perform useful work in a subsequent conversion process is known as the very equivalent. During each operation, energy is diminished due to entropy generation, which corresponds to the waste heat generated at a low temperature. And the third is implication. Implication of understanding exergy. Exergy analysis can inform decisions about energy system and technologies, helping to optimize energy use and reduce waste. By understanding exergy, we can make more informed decisions about how to use and conserve energy, ultimately leading to more sustainable practice. Next, I will explain about background of the study. First, efficiency. Efficiency is limited by the Carnot cycle maximum efficiency, determined by the temperature differences between the engine and coal reservoirs. Second is rear engine. Rear engine have lower efficiencies due to factors like friction, imperfection composition, and heat loss. Second, innovation and improvement. This is aimed to reduce energy loss, increase power output, and minimize pollution. Minimize pollutant.
Okay, hello and Assalamualaikum. My name is Muhammad Taufik Hakim Ibn Muhammad and my metric number is MA23043. So today I will talk about literature review. So firstly, you must understand the first law and second law of thermodynamics. First law is talk about energy can be only converted from one form to another. They cannot be created and destroyed, and also known as the law of energy conservative. And second law is talk about they introduce the concept of entropy. Entropy of an isolated system increase over time. So next is we go to heat engine. Heat engine is divided by three. First is Carnot cycle, second Otto, and the third is diesel cycle. So Carnot cycle. So firstly is Carnot cycle. Carnot cycle is represent the maximum possible efficiency for heat engine. They operate between two thermal reservoirs. And next is Otto cycle. Otto cycle is consists of two adiabatic and two isochoric process commonly used in internal combustion engine. And lastly is diesel cycle. Diesel cycle used in diesel engine with isobaric combustion. They have higher compression ratio, lead to the greater efficiency compared to the Otto cycle. And lastly is advance in heat engine efficiency. Firstly is regenerative cycle, increase overall efficiency by reusing waste heat. For example, the Stirling and Irradiation cycle. And lastly is combined cycle. Enhance efficiency by combination two or more thermodynamic cycle. For example, Brighton and Rankine cycle has combined.
Assalamualaikum, my name is Muhammad Fakhr Haziq, my metric number MA23074. So I will present for my slide. A dual fuel engine is type of internal combustion engine designed to operate on two different types of fuel simultaneously or independently. Typically, this engine uses a combustion of gaseous fuel such as natural gas or biogas and a liquid fuel such as diesel or biodiesel. The primary fuel gases serves as the main energy source, while the secondary fuel is used to ignite the mixture and ensure stable combustion. So here is schematic diagram of gasoline engine. So this is some of the factors affect the combustion process in a dual fuel engine. First is fuel ratio. The proportion of primary to secondary fuel gas to diesel ratio significantly influence the combustion process. An optimal ratio ensures efficient combustion, whereas a suboptimal ratio can lead to incomplete combustion, higher emission, or knocking. Second is injection timing and duration. The timing both the primary and secondary fuel injection is critical. Injecting the secondary fuel at the right moment ensures ignite the primary fuel air mixture effectively. The duration of the injection affects the quality of fuel delivered, influencing the combustion process and engine performance. The third one is compression ratio. The compression ratio of the engine, which is the ratio of the cylinder volume at the bottom of the stroke to the volume at the top of the stroke, affect the temperature and pressure of the air-fuel mixture before ignition. So this is some of the benefit of dual fuel engine. First is environmental benefit. When operating on a mix of natural gas and diesel, dual fuel engine produce lower level or harmful emissions such as nitrogen oxide, sulfur oxide, and particulate matter compared to diesel-only engine. Second is economic advantage. The use of natural gas, which is often cheaper than diesel, can result in significant cost saving. This is particularly beneficial in regions where natural gas is abundantly available and economically priced. Third is fuel flexibility. Dual engine can operate on a combustion of gases and liquid fuel, or exclusively on either fuel type. This flexibility allows for continuous operation even if one type of fuel is unavailable. Also, operator can take advantage of fluctuating fuel price, the cheaper or more readily available fuel to minimize operational costs.
Okay, so for formula analysis, we have three formula for Carnot cycle, Otto cycle, and diesel cycle. So for Carnot cycle, we have isothermal expansion, adiabatic expansion, and efficiency of Carnot engine. And next is for Otto cycle. Otto cycle have isentropic compression, constant value heat addition, and efficiency of Otto cycle engine. And lastly is diesel cycle. Diesel cycle also have isentropic compression, constant pressure heat addition, and efficiency of diesel engine. Okay, that's all from me. Thank you.
Hello everyone, I will continue our presentation. I'm going to talk about the result and discussion. This presentation will cover basic principles of thermodynamic cycles, efficiency, performance metrics, thermoeconomics, and strategies to reduce exergy losses. Okay, heat engines work by converting heat energy into mechanical work through three main types: heat intake, work output, and heat rejection. The first law of thermodynamics governs this process. As you can see at the slide, this is the diagram that was related. Next, heat engines operate based on specific thermodynamic cycles, including the Carnot, Otto, diesel, and Rankine cycle. Each cycle has distinct processes and characteristics that define its efficiency. Furthermore, the Carnot cycle is an idealized thermodynamic cycle that represents the maximum theoretical efficiency. Efficiency is determined by the temperatures of the heat source and sink. Moreover, analyzing Otto, diesel, and Rankine cycles help understand their efficiencies and influencing factors. For example, higher compression ratio in Otto and diesel cycles lead to greater efficiency. After that, real heat engines are more efficient than the theoretical Carnot engine due to high reversibility such as friction, heat losses, and non-ideal gas behavior. The efficiency of a real engine is defined as the ratio of useful work output to the heat energy input. To improve this efficiency, engineers focus on reducing this high reversibility and optimizing the thermodynamic processes within the engine. This is an example in this slide what I was just said just now. Several strategies can improve the efficiency and performance of heat engines. First, increasing compression ratio. Higher compression ratio lead to better thermal efficiency, especially in Otto and diesel engines. Second, turbocharging. This forces more air into the combustion chamber, increasing power output and efficiency. Lastly, advanced materials. Using materials that withstand higher temperature and pressure can improve engine performance and durability. Meanwhile, evaluating the energy performance of heat engines involves several key metrics. I will talk only 3 points right here only. First key is power output. This measures the actual work produced by the engine. Besides that, specific fuel consumption. This indicates how efficiently an engine uses fuel to produce power. Lastly, thermal efficiency. This is the ratio of work output to heat input, indicating how well an engine converts heat into work. In addition, thermoeconomics integrates thermodynamics with economic analysis to evaluate the cost effectiveness of heat engines. Currently, I only present 3 of it. Number 1, cost of energy production. This involves calculating the total cost connected with producing power, including fuel, maintenance, and operational costs. Number 2, life cycle cost analysis. This assesses the total cost of ownership over the engine's lifespan, considering initial investment, operational costs, and disposal costs. And number 3, environmental costs. These include costs associated with emissions such as carbon taxes, penalties, and the social cost of pollution. Engines with lower environmental costs are more sustainable and can be economically positive in regions with strict environmental regulations. SG loss refers to the loss of useful energy that could be converted into work due to high reversibility in the system. Here are strategies to reduce those losses. Same as before, I only explain 3 main strategies, which are minimizing frictional losses. Use advanced lubricants and high precision manufacturing techniques to reduce friction in moving parts. Secondly, optimizing combustion processes. Use advanced combustion technologies like direct fuel injection and turbocharging to improve combustion efficiency. Last but not least, improving heat exchange efficiency. Employ high efficient heat exchanger and maintain them properly to enhance heat transfer. Okay, thank you. That's all from me. I will pass it to my partners. Thank you.
Conclusion for heat engine. First, research on improving internal combustion engine performance through energy and exergy analysis. Second, evaluate engine characteristics like output power, temperature and pressure using experimental data collection and simulation method. Third, performance can be changed by adjusting compression ratio and implementing advanced combustion technologies. 4. Way to improve efficiency include increasing compression ratio and reducing energy losses. Lastly, provided detailed methodology and suggest way to reduce energy losses, such as using alternative fuel and optimizing compression ratio.